So that's us. This is a world first. CCM, Burnt and Neil across the world. So welcome the people that are already logged on. I think we're expecting, I think we've got 10 or 12 at the moment. We should be talking with Brazil, Germany, Finland, India, Philippines, Portugal, Romania, Saudi Arabia, South Africa, Finland, Turkey and the USA, and Singapore. So that's Leslie in Singapore. So I hope you're there. I can't see. There's a computer that Bernd will be managing in a second. We're just going to wait for another few minutes before we get started. Make sure that we've got as many people on board as possible. And I should be talking to this computer, not the one over there, this screen. So, so what will happen through this? Well, it's not a presentation; it's interactive. So we'll be talking amongst ourselves, albeit that your questions will be in text. So if you've got a question, you just fire it off. Nothing obscene, please. Bert is easily shocked. You fire off the questions, and we'll pick them up at the end of each section. So what we'll be doing, we're going to be looking at all of our fabric coatings together. The main focus is on our new hot stuff range of technology, but we'll talk about the basic coatings down to this new range, so you've got a full feel for the whole portfolio. And at the end of each, as I say, the first thing that we'll be talking about will be revisiting our standard fabric coatings. So that we really understand the dimensions, what's in the bottle, and then we're going to get onto the new stuff, which is exceptionally exciting. So you've got Bernd here. I'm going to send him back to his computer in a minute. That's his job over there. So he's going to be working over there, and he's our moderator. And so we've got a few more now, and so I'm going to press ahead. So to start at the very beginning, as they used to say. Anybody who was English of my age will know that was the start of a television program. So we're going to start off with our basic fabric coatings. So we have our world famous now, and actually some of these really are world famous technologies. We've got our universal coating. The universal coating is a 695, is similar, they're all quite similar. But let's take this. What do we have in the bottle here? And you'll see later on when we explain these, we will construct something like this for the industrial coatings, adding a few more agents. So in here, remembering we've got silicon dioxide. The silicon dioxide, it is essential to note, is not nanoparticles. I got an email today from a company in Sweden who said, "Oh, we don't do with nanoparticles. We deal with amorphous silicon dioxide, no bits. There's nothing to inhale like a bit that's going to break off." Well, ultimately, when it's on a coating, you could theoretically, it's like everything else, you could abrade a piece off, but and we all know that that's not an issue with SiO2. So we've got our silicon dioxide, and that's the same as in our industrial variant. This is really going to be very, very important, because this is what gives us the strength. In our coatings, they're much stronger than anybody else's, or anybody else that doesn't use an SiO2 base. So inside here, silicon dioxide. Then we have some fluorinated agent. Now, in a minute, we're going to be going through a document together which addresses C8 technology down to C6 technology. In simple terms, C8 technology is bad and dangerous and kills you. C6 technology, there is no data about that causing any problems whatsoever. And we are using variants of C6 technology in our coatings. So, silicon dioxide, that gives us strength. Lots of durability. C6 technology, that is not known to cause any problems. One has to assume that there aren't any problems. and water, and any other agent in there has no significance whatsoever. They're parts per million that are part of the construction of this technology. Otherwise, in simple terms, it is silicon dioxide, water, and a little bit of fluorine. So that forms the basis of all of our DIY coatings. Those are all air curing coatings. They are fantastic, they do the job. Anybody who's used them, we still supply a great deal of this. Anybody who's used them knows that they will last for a long, long time. Probably longer than the person on that motorbike. But if you could hear that motorbike going past. So, when we're talking about our coatings, we're starting off with this is our standard coating. Right, we'll come back to that in a minute. The next thing though is that we're moving from our standard coatings and introducing something that's really very, very significant in the world of fabric coatings. And it's significant to the level that we are there with the big boys. In fact, we are ahead of the game. This is one thing that we can say. If you go along to any company and you say, I've got a coating that is going to perform like our hybrid coating, they are going to really be interested. This last week I was talking to a consultant from a massive group. Just so happens we had this conversation, a multinational group, and we were talking about what he was saying, what's out there. That's his job. His job is to find out what is best in the world to solve problems. And he was saying, well, we've got something that will take 70 wash cycles. And I said, yeah, well, we've got something that will take 100 wash cycles. All proven, all tested. He said, ooh, wow, that really is significant. So what I'd like to do, as I said, we'll come back to the DIY spray-on fabric coatings, but so we start from here, and now we're introducing the heat-treated coatings. So let's get started with that. Bert, could you pull up the document there? That's just an image of something, again, we'll be looking at. So, I need to explain what we've got here. Hybrid fluorinated nanosilica fusion technology with self-healing characteristics. Actually, the next time that you see this document, it will have our brand on there, which is Hot Stuff. You'll see that in a minute. And everything else pretty much the same, but we're branding these new technologies as Hot Stuff. We've got it trademarked, so we're fine. And nanosilica, that's what's in this bottle here. So we're using exactly the same base, tried and tested, massively durable, doesn't cause any problems, we know with silica. But hanging off this core technology, we're now adding some agents that when we mix them together and heat them, they bond incredibly strongly. This dries at room temperature, it's got good bonding, exceptionally strong bonding, but when you put it you heat bond it with the special agents inside there, you've got a massively stronger bond. And so it's an industrial process. So very simply, we take the SiO2, and we'll come to this, but this is basically our industrial variant, excuse me, reaching across there. This is our industrial variant. So we're going to be taking our standard SiO2, it's in there. We've got a bonding agent that we take up to, that's like the super glue, that really bonds it very, very hard together. We've got a wetting agent, that means that it flows nicely and goes over the fabric very easily. And we've got another special agent in there that also allows it to bond, and we can't tell you too much about it anyway, because these are the special things. And if we were to tell everybody exactly what's in there, then we wouldn't have a business. None of us would. So Okay, so it's hybrid. We know, everybody knows what hybrid is, an adaptation, it's something special. So we've hybridized, I don't know, come to me in a second, hybridized, excuse me, our basic technology. We fused it together with other agents, and then we've got self-healing characteristics. So what does self-healing? It all sounds very fancy and fanciful, and is it really valid? Of course it is. What happens is that when we manufacture this fabric, so let's imagine there's a massive mill, and we put the heat bonded coating on, and off it goes into a roll of fabric, and you've got a piece of fabric the size of this room, or thousands of meters. If you take that and wear it and kick it around, and in a week later you say, oh, it's time to wash whatever it is. What happens with this coating is that you put it in the washing machine, and normally, as we know from using our DIY coatings, the performance drops off. 2 or 3% every time. But with this coating, you put it back in, you wash it, and you dry it in the tumble dryer again, and it realigns the structure, and you get unbelievable performance yet again. Now, the only other thing there, that when this is what we're coming to in the next section, is the reference to fluorinated. So now I want you to, Bert's going to now go to the next page, and we're going to work through this together. And the reason that we're going to do it in such a teacherly manner is that I want people to actually, when they take this document, under whatever brand they're working, that they fully understand it, because that's the whole point of this session. If you fully understand it, then you don't have to ask us questions. So, in the first paragraph, it tells us the fabric industry has been searching for a coating which offers the same performance as C8. Now, that in the old days, when you had a Teflon coated, it could have been Teflon coated jacket for the military, it worked really, really well. It was a bit sticky to touch. It didn't feel very, very nice, to be quite honest. And it was a comparatively thick coating, but it definitely did the job in terms of hydrophobicity and oleophobicity. Now, the only downside is I'll read through this, yet with the obvious negative attributes, it became apparent that a technology based on, I'll reread that, sorry. The fabric industry has been searching for a coating which offers the same performance as C8, PFOA technology, yet with the obvious, without the obvious negative attributes. And it became apparent that a technology based on SiO2 could prove to be to offer the solution. And this is indeed proven to be the case. Now, the negative attributes are that C8 technology has been withdrawn, should be withdrawn, because it is bioaccumulative. That means that it persists pretty much forever. Not for your lifetime, but for your children's children's lifetime. And so this technology is everywhere, especially in America. It is, because it was used most widely in the US. It's been used everywhere, but very, very extensively in the US. And it is bioaccumulative in that it goes into our bodies and hangs around and causes us problems. And it is environmentally accumulative. So it's in the rivers, and it can be traced absolutely everywhere. Now, that is a problem. That was the main agent that we've used in all of our cooking utensils, Teflon. We used it on coating all of our fabrics, and very simply, it was washing through our system and causing lots and lots of problems. So we had to get rid of it. The only problem is that if you get rid of it, what happens? You don't have polyphobicity. But just I'll throw this in now. Our coatings, as we'll talk maybe a little bit more in a minute, the coating that we're presenting now is massively oleophobic, so stain resistant, massively, and it is also hydrophobic, of course. We can create this technology. So if a partner said, I just want hydrophobicity, I want a washable coating that can put into the washing machine 100 times, give fantastic performance, and I don't want any fluorinated agent in, then most definitely we can provide that as well. Bernd, I notice, are you noting a question? Oh, it's just, is the question Bernd, or is it, no, it's just people logging on. Okay. How many people have just logged, just in the last few minutes, Bernd?
Around 20.
About 20. So, welcome to all the people who've just logged on. I will, hopefully, you'll have, I started off, just recap, I started off with talking about our basic technology, which is the backbone of everything that we do on our fabric coatings. That is silicon dioxide technology. And I've explained that we've got our spray-on variant, fantastic, works every time, easy to use. You can't always heat things up. But now we're looking at our industrial variant, which is our heat-coated variant. So we now go to, if we look briefly in the background section, it tells us that Greenpeace recognised and did all the research and identified that that CA technology, Teflon, in simple terms, was bioaccumulative and causing us lots and lots of problems. So what we're using is C6 technology. Now, this is really very important. If you present yourself up to a fabric finisher, fabric manufacturer, somebody who's doing clothing or whatever, they will turn around and say, oh, the world is concerned about all fluorinated agents. Okay? To a degree it's valid, because we know that C8 was harmful, and we're proposing that C6 is not harmful. Now, there is no data anywhere to say that C6 is harmful, so we're sticking with the notion, the idea that C6 technology is the only game in town. It is the only game in town at the moment. If you want oleophobicity, you have to have a fluorinated agent in there. We've gone with C6. If your very, very large company were to say, I don't want C6, I want to go down a step to C4, which is just, it's in the same family, but not in the bad range, not in the dangerous range, that's possible. So you're going to take exactly the same framework of technology and reduce the oleophobicity a little bit. So you're going from a C6, super oleophobic, down to something that is still very hydrophobic, but not quite as oleophobic. And if the people that you're dealing with say, we don't want any fluorinated agents inside there, you say, okay, you still get 100 times washable, depends on the fabric, we'll discuss that. So you still get 100 times washable, but you don't get oleophobicity. And at the moment, it's an either or. And if they're saying, well, we want oleophobicity, then they're going to have to go with this. There are still people manufacturing very well-known garments are still being manufactured with C8 technology, even though it's in essence been banned. It's got another 18 months or something like that before you cannot use it. But the world is looking most definitely away from C8 technology. But it is still there. I could name the brands, but I don't know, I won't do it just in case there's litigation. But major brands have got C8 technology on their fabrics that they're making today. Okay, now you can refer to the document there, and it will tell us that there are there's no testing on on C4, C6 technology, that says that you've got any issues. Talking about the olephobicity, just to give you some idea, if you were to take a fabric and coat it, we're going to do some later today. I'm going to show you how to do it yourself in-house. If you were to coat a piece of fabric today and put an oil drop on, I would expect that that oil drop would sit there for a week without penetrating. Everything else, I mean, it's olive oil typically, and it won't leave a stain after the week. It's so oleophobic. The next and really, really important thing is that because of our technology, the amount of fluorinated agent is infinitesimally small. Now, in the old days, if that was a tin of, or a spray-on of Teflon type C8 technology, it would be, let's say for the sake of argument, 50% Teflon, and the other would be a carrying agent. So it's really heavily laden in Teflon, C8 type technology. What we're doing is we're taking our standard technology like this and putting a tiny amount of fluorine in there compared to any other technology. So people go, oh, I don't want C8, C6 technology. Okay, but you have to remember that we are talking about infinitesimally small amounts because of the way that we bond it all together. So our structure is so different to anybody else's. So this little sprinkling, the old Teflon technology was completely dependent upon Teflon, or to be more correct, C8 technology. Ours is totally dependent upon SiO2 with a little smattering of C6, excuse me, in there to give us the oleophobicity. And we can give you the data. It's just very, very small. The next part is that because of you start off with the infinitesimally small amount of C8, C6 technology in there, and because of the way it's bonded to the fabric because of high temperature, it doesn't wash off. So you start off with a tiny bit, and then you make sure that it just doesn't, because it's bonded, it's not disappearing onto our skin, into the home, and into the environment. So that's really very, very important, because you will come across the debate about C6 technology. Oh, we don't want any at all. Okay, well, have the coating without the C6 technology. Right. If you turn over, or go to the next page, Bert, thanks. So, people talk about long chains, C8 technology, and the shorter chains, C6 technology. These are the important things to remember here. So, fabric coating technology available until now, we've just discussed this. Long chain C8, biomagnification and bioaccumulation toxicity prompted by UV light. So, apart from the fact that it's now recognised as being very, very bad, when it's subjected to UV light, it becomes even worse. So, and there's a lot of UV light around. I'm sitting in a room now with UV light in, but if you're in somewhere with a lot of sunlight, it breaks down even more readily. But then we look at the short chain C6 technology. Ultraviolet prompts a degree of release into the environment, recognised as not being bioaccumulative, lower performance than C8. However, melding C6 with other technology can enhance performance. So, we started off 10 years ago, super high performance with Teflon, with C8 technology. Let's say 10 out of 10. Everybody's very, very pleased. What we managed to do is we use C6 technology, we take most of it out, so it's just this tiny, tiny amount, And we do the impossible. We get 11 out of 10. We're higher performing than the old technology that was laden in C8 technology. So we've done something really very, very clever with that. Okay, moving on down. You can read any more details in there. I just want to give you the basic background. This little chart here, we want to just show you. So, this chart shows the performance of standard commercially approved applied fabric coatings. The maximum oleophobic rating after 10 washes is only 5. So it reduces. Of course it does. It's a form of abrasion. Fabrics are mobile, they break, they move around. But if we look at ours, after numerous washes, it has a much higher oleophobic rate than anything else. It's in the, I don't want to pull it apart just at the moment, but it just shows us that we've got a much higher rating. Top right hand side, CCM hybrid fluorinated nanosilica fusion technology with self-healing. Somebody will say, oh, well, what happens if we don't have, we can't put our garments back into tumble dryers? And this is a completely valid point for certain environments, certain countries, where it's so dry or warm that things are dried out outside. You don't get zero performance, but you don't get the high level of performance that you had before. You will be in those instances. You'll be better off using a standard coating, which is an air drying coating. It dries at room temperature. So there is. It's not a weakness, it is the way it is. This technology is predicated on being applied and tumble dried afterwards to get that very, very high performance characteristic. But most people in the modern world, I say modern world, in Europe will have access to tumble dryers. But we're talking high performance here. Having said that, we'll come on to our other DIY hot stuff. That might fill the gap a little bit more. But manufacturing, if you're talking about making army uniforms or anything like that, then this is the coating for you. So I'll read that. Our experience of working with SiO2-based coatings informed us that this technology has offered the best foundation from which to create a new coating. The main obstacle to overcome was enhancing the bonding characteristics of the coating. This obstacle was overcome by creating a hybrid matrix, which when heat cured would provide a coating which would not only match but supersede the performance characteristics of standard C8 coating technology. Now, we've already been through that, but it's this point, and this is unscripted, so I have to come back on some of these things. It reminds me that if you're making fabrics for a car seat, for example, you don't take your car seat out and wash them. So this will last because it's massively, massively durable. You're not going to take it out and wash it. You might sponge it a bit, that won't have any negative impact on it. And this is going to outperform anything that is available now by a country mile. There will be nothing that will be able, if you put this and heat it and put it on a car seat, there is nothing on the market anywhere in the world that will match this. That's our belief. And talking to experts across, some of them who've worked with across the world, are saying, no, there's nothing to touch this. Right. You've got attributes there, PFOA free. The main thing is the outstanding oleophobicity that we can achieve with that tiny, tiny amount of C6 technology. Right. If you turn over, or you scroll up to the next page, people want to know that what exactly we're talking about in terms of, you claim this, you claim that. Well, it's all based upon this famous AATCC washing test. Now you can find the data from that anywhere, just put it into Google. And it is the standard. This is what all the companies use when they're washing. Now, it is important to note that this shows a washability component. It doesn't say anything about wear, but none of them do. So if you say you could have a technology that you can wash 100 times and has very, very poor wear characteristics. Sounds a bit crazy to say so, but it's possible. You could have it, whereas this, we know from personal experience, because we do a lot of in-house testing, as you know, we take it, we braid it, we wash it, and we can confirm that it is both very washable and very wear resistant. Which then brings me to this up to 100, or washing stability 25 to 100 washing cycles. Why could it possibly be the case that it works 25 times on one fabric and 100 times on another fabric? It's very simple. If you put it onto a cotton-based fabric, for example, then that's your 25 wash cycles, realistically. If you put it onto it's a cotton polyester, you're going to be moving into that 50 wash cycles. If you put it onto a polyamide type, you're getting into that 100 wash cycles. So it all depends upon which fabric you're going to be applying. There is no absolute on this. But again, we're ahead of the game. So that's very, very important to recognise. So, but it will not, somebody gives you a cotton t-shirt and says, we want this to last 100 wash cycles, the answer is no, it won't. But it will last a lot longer than anything else that's available. Everything's tested against the AATCC methodology, and in that they use specific washing powder, specific time in the washing machine and loading and so on and so forth. But it's the norm for all washing for all fabric testing. It gives us the oil repellency data, which you can refer down to below. It's exceptional. Oil repellency, water repellency, very, very high hydrophobicity. Again, essential to note that we are still not making things waterproof. We are waterproofing the fibres. We're not waterproofing the fabric. We've talked about this before. If you take something like this jumper that I'm wearing now, I can look through it, I can see the light, I can breathe through it. It's 50% holes. So fabric holes. I can't make that well, I could make it waterproof if I put a really thick coating on it. We do have those coatings, but we'll call it Me Too coatings. They're thick resins and stuff like that go on. They fill all the holes. We are still only covering the fibres. And this coating is in that approximately a micron range. This coating is in that 200 nanometer range, 150, 200 nanometer range, much, much thinner. This is in that, because it's a little bit thicker, in the micron range. Still very, 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 very thin. Bearing in mind a hair's in that 10 to 15 micron range, approximately. So it's still very, very thin. Highly stable temperature, transparent, outstanding UV stability, great washability, as we know, good stability from chemical cleaning. Good stability from chemical cleaning. Right. What would that mean? That means that if you put it into a dry cleaners, it wouldn't go the first time. Many coatings are just not designed for dry cleaning. If you need to move on to something that has very high dry cleaning resistance, let's say 15 dry cleaning cycles, which is a lot. If you wanted something like that, again, that is available. This is always about bulk, this particular technology. It's always available as a concentrate to make 1 ton. And it's the same. If you said, I've got a company and they want great hydrophobicity, good oleophobicity, not great, because we're having a trade-off here, but they really need this garment to be dry cleanable. And they want it to be dry cleanable 10 times, 15 times, something like that. Then we can alter this structure, take out an agent, put another agent in. It'll be still the same backbone, but you will lose out on one of the aspects, but it's doable. So, the industrial application. We're going to mix some in a second, but it's really very, very straightforward. You mix it in a big container, so you get an IBC, and that IBC you put 960 litres of water in there. If the water is sufficiently clean, then you can use local water. If it's like in Uruguay, where it's very heavily laden with ferrous deposits, not to be recommended, so then you would have to have distilled water. But if the water is clean and stable, not too much calcium, not too much ferrous characteristic, then you should be able to use it. So you take your 960 litres of water, you take the pack which is supplied by us, you empty the pack in, you stir it around for 5 minutes. You don't, just stirring it around with a paddle of any sort is, as long as it's distributed evenly, that's the liquid. So what happens then? You take the liquid and you put it onto the fibres. Now, there'll be stenting, padding, you could spray it on, all we're interested in is getting it onto the fibre in a sufficient manner. It's very, very easy to use. It's water-based coating, obviously, very easy to use. So the normal procedure would be the fabric would roll through a bath, taken through a bath, moistened the fabric squeezed, then it goes through an initial dry, and then it's heated. So let's be more precise about that. So the fabric comes out from the machine. It is usually hit with a big hairdryer, and then it can go through two or three. It can go over hot rollers, it can go through an infrared lamp system, or it can go through an even bigger hairdryer. The target temperature is 150 to 160 degrees. 150 is on the low side, 160 is about right. You can take it up to 170 degrees. So, how long? So you've got to get to that bonding temperature, because of course that's the temperature when these agents start to really bond. It's like a glue, really. So they bond to the fabrics. If you don't get it up to that temperature, you won't get the bonding. So the only questions you have to consider are, will the fabric accept that temperature? Now, I was doing a project on bedding, and the people wanted to coat the bedding fabric, and that was backed by one of these iron-on layers to make it firmer. So they take a fabric, which is I forget the actual structure of the fabric, it doesn't matter, but it was bonded with this material. And very simply, when I got to 140 degrees, it just went, and it didn't quite dissolve, but it shriveled and whatever. It was never going to happen for that particular temperature, for that particular fabric at 140 degrees. So you can't do everything. In a minute, we'll do a little demonstration. But the long and the short is, that's our target temperature. So let's move on from that. Target groups for the, it says here on they've got the amended document built with the low temperature reference. Oh, they have. Yeah. Since this document was produced, the low temperature variant has become the norm. So before we were working at 170 to 180 degrees. Everything is in that, we're using the low temperature variant, and we've managed to make that, which is better, make it more cost efficient, because the initial interest has been so high, we've said, right, we're only doing the low temperature variant, that's that 150, 160 degrees. Up to, you can take it to 170. Then the question is, how long? Well, it depends upon the fabric. If it's a light cotton fabric, then it's 60 seconds. If it's a very, very thick fabric, for example, something like this jumper. Say you wanted this a sports jumper and you want to make it waterproof or stain resistant, it's going to take longer to do the jumper that I'm wearing than to do the fabric of a shirt. So it has to be, all companies know this, it'd probably be between 60 seconds for the light fabric and 90 seconds for the heavier fabric, maybe 120 seconds. We can't stipulate, that's a matter of testing. Right, and at the bottom there we've said just some target groups for the textile. We've got military, hospitals, workwear, you can read all those. The one that I wanted to make reference to is upholstery. We are working on formulating something, this will be made clear, that will make it fire retardant. So if you have upholstery for a hotel, it has to be fire retardant. So we are working on, you can coat the upholstery and for domestic applications and so on and so forth, it may be that fire retardancy for a cushion is not required, but we're working on a fire retardant variant about that, so we'll update you about that. These things never stop, do they? We're always pushing forward. So that's our industrial variant. Anything that I'm looking to Bernd here, anything that any questions? You guys, please feel free to ask any questions, because that's why we're doing it this way. So it might be, we'll do all the practical stuff together, I think, Bernd. So should we go on to the hot stuff, the retail variant? Right. So that's 150 degrees. Well, so that's air drying. That's what you can heat it, of course, but that's spray it on, and the next day use it, and it's perfectly good. That is our hybrid heat to 150 degrees. Got to do it on large manufacturing areas. So industrial, DIY. Now we're bringing up something that is really, I think, is exceptional. Everybody else seems to think it's exceptional, and it is. We think it's pretty much a world first of its type. So, what prompted us to create the Hot Stuff brand is this little chap here. This is our DIY variant. It takes the best of this and reduces the heat needed and also allows us to do it on a DIY basis. And we're introducing a whole range of hot stuff products and technologies. It's the same technology, but we're just branding it as hot stuff. And if you might as well show people the hot stuff brand burn if you could. So that's our first pack, and you'll see the hot stuff logo, and as I say, that's our trademark for this. And that's photographed there. If you could zoom into that burn for the training shoes. And we've got these ones here. These were taken by our master photographer, Bernd. And on the left is an uncoated training shoe, and on the right is a coated training shoe. These are real time. You can't falsify those images. And again, that's another afterwards there. So you can see the socks on, that's Bernd's daughter's, on her right foot. You can see the socks have got mud and things on, and there's some soiled water about there, of course, but nothing penetrating, nothing staining. That's just what it does. So that's our hot stuff for sneakers. And what we will be providing is the hot stuff pack will come with some gloves, the hot stuff liquid. It's going to be in sachets. That rip off a sachet, pour it into the water, mix it and apply it, which we will do in a second. And again, it's called hot stuff because it has to be heated, but it doesn't have to. It doesn't have to be heated with at 150 or 60 degrees. This will be fine at 50, 60 degrees, which is a tumble dryer and or a hair dryer. You'll get performance even if it's not heat cured, but it's not as good. So it really should be heat cured. Just hit it with a hair dryer. And so our target is, say the brand is going to be for sneakers. So you take it, I'll show you in a minute. You take it, add it to the water, put it onto your sneakers. In the US, for example, we'll be doing it with a sponge because they're phasing out spray applications of fabric treatments. And so you just sponge it on, moisten the training shoe. And for Europe, we're putting it so that you mix it, add the water, you get a little 100ml spray bottle, pour the sachet in there, top it up with water, spray it on, let the training shoe dry in the sunlight or on a radiator, and then put it in the tumble dryer or use a hair dryer, or conversely, put it straight in the hair dryer or use a tumble dryer straight away. This is heat cured to, as I say, 50 degrees, which allows us far more versatility. That's stage one, project number one, this is another box design. We've decided to go with black, but it will be something like this. But then, in the future, let's say 6 months from now, we're going to be presenting these, the liquid in a DIY domestic variant, so that if you wanted to do a jacket or any bit of clothing, or your curtains, one of the curtains at that instance, and that will be a bit like Nick Wax, which is the market leader. Now the big difference is that if you take the standard wash-in products that are out there, which are basically waxes, they're fine. They are hydrophobic, which is good, but they have no oleophobicity, no stain proofing. So you put a drop of oil in, it goes straight through. Red wine, straight through. Whereas this, not at all. And so in that image of the training shoes, that all of that mud and whatever, the contaminants from there would ultimately go through onto the white training shoe. Now, so what we'll be doing, we'll be offering the hot stuff in a bottle. You just just take it, mix it. We're going to do that in a second. Take it, mix it, stir it, put the item in, and put it in the tumble dryer. We're also then going to introduce a larger bottle. Let's say it will be slightly smaller, but let's say 500 ml. And that's if you wanted to do your curtains or your larger bits of three-piece, your covering for your settees and things like that. Then we're going to do a larger bottle still, and then a 5-litre container for companies that want to actually do this as a service. So if you've got a dry cleaning company and somebody wants to bring in their it could be a lot of clothing, it could be a kit for a football team, or it could be, as I say, the covering for a settee. You could do it at home if you've got a big enough tumble dryer, but that's for larger scale usage. So there will be a whole range of hot stuff products out there, and these will be co-branded. So they'll have hot stuff on there. That's our brand. We'll stick with that through everything, and then it will, wherever it may be that you want to do a co-brand, but it will be and it is an advantage to have the hot stuff brand, because the reception that we've had for the branding has been really positive. So let us have a look at some of the practical side of things. So I'm going to start off. How are we doing? We've been going for an hour now. We've been best part. Nobody's asked a question?
No, just a hello from Shady, and that the packaging looks nice.
Oh,
thank you very
hi
much.
Shady. Name check here from Radio CCM. And so please ask the questions now, because that's the whole point about this. Right. But really think of a question, because as soon as we put the phones down, or not the phones down, it's off. This is the time to ask the questions. Right. Let's start off with the little brother to start with. And so let us imagine we open our packet of hot stuff. So here we have our hot stuff liquid. And this is 200 mils of water. So the person, if it's in the US, they'll get 10 mil, and all they'll do is that. So we add the contents to 200 mil. That is, and this is really very important, that is the recommended. Training shoes take a lot of wear and tear, and so we've got to give the optimum coating. For training shoes, we've tested, we've worked it out, and at the costs, etc., you could make it 1 to 30, but 1 to 20 is the best. When we move on to the next DIY packs, we'll say for optimum super high performance 1 to 20. If you're coating something like a set of curtains, it would only be 1 to 30, maybe even as far as 1 to 40. Curtains do not take a great deal of, if you're just going to get sprays of liquid in a restaurant on and you just want to be able to sponge them off, they don't need lots of washability. This, remember, is very washable. This coating, that's the whole point. And so we'll be going from 1 to 20 up to maximum 1 to 40. But we will offer that information on the pack, and we'll say very high traffic and wear, etc. 1 to 20, 1 to 30 for cushions, seating, settees and stuff like that, and areas, fabrics that just need to have hydrophobicity, oleophobicity, 1 to 40. Okay, so back to our training shoes. So that's now, so we're not doing training shoes because it takes too long. So I'm going to take a piece of fabric. This is white cotton. Now, what am I going to do with that? I've got two options. Firstly, I hang it someplace, put it on the line, it might be a shirt, and then I'm going to come back in a couple of hours from now, it'll be dry. And if it's dry, then I'm going to either, if it's a pair of training shoes, I've put it outside in the sunlight, I'm just going to get my hair dryer and dry it. We'll look at that as an option in a second. Or if it's a shirt, I'm going to put it in the tumble dryer. So it's been out the line, it's dry. Probably in Saudi, where shady is, in the summer, you wouldn't need to put it in a tumble dryer. But you definitely wouldn't if 50 degrees, which you will get in certain instances, will be sufficient. But you take that and into the tumble dryer, and that's it. It'll be high performance. So here we've got another example. We're just going to do it now. I went out and bought myself a shirt for this.
We have 3 questions.
Questions, great.
What about leather boots from Radu in Romania?
Leather boots, okay. Leather, we've done the testing on leather. On suede, this will work. You can sponge this onto suede, spray it onto suede, and it'll work. On leather, it depends upon the level of absorption of the leather. If the leather is very absorbent, it will work on leather. We do have a leather coating that is better for most leathers. So I'd be careful about leather. Suede, fine, because suede is very different in structure. And if you could do it at leather manufacturer. So for this, I've tried the industrial variant on leather, and it works very well, and it doesn't kill the leather, much to my surprise. The industrial variant, I thought at 150 degrees it's going to make the leather hard or something. It doesn't. So it's worth looking at. If you've got a leather manufacturer, it's an option. It's an option. I was surprised that it worked. But from a DIY point of view, I would recommend we have a leather that's a penetrative type thing, and that will definitely go into the leather. So I hope that answers your question.
Okay. Then Rian from South Africa.
Hi, Rian.
How many washes will the sneakers handle as hot stock before the coating is no longer effective?
Right. It is between 10 and 40 washes. My information tells me that it's a minimum of 10. The absolute minimum. Which is quite a lot. And to recoat it, you just do the same procedure. The really interesting thing is that the hydrophobicity and the stain proofing, we'll show you some images in a second. The hydrophobicity stain proofing is really excellent. But if you take olive oil, and push it into the surface of the training shoe, you will get a mark. As we know, the olive oil penetrates, finds its way in all the little gaps. That's what oil does. But if you take that and clean it, the first time you'll get nearly all of the olive oil out. There's always a little traces in behind, but eventually it comes out. So the next time you wash it, and you've got an olive oil stain, you wash it and it's nearly all gone. The next time you wash it, it's all gone. It continues to come out. It really is that strong. So it's 10 to 40 washes. But I would say on these canvas training shoes, definitely 10, which is a lot on a canvas shoe.
Okay. Dominic from Germany. asked if the hot stuff product is bacteria inherent.
All of the coatings inhibit bacteria because they're all biostatic, because they create an environment. They're all cationic, and we all know that cationic surfaces are not suitable for proliferation of bacteria, development of bacteria. And also because they're hydrophobic, they prevent bacteria having a lot of nice moisture around to develop. Are they antibacterial? No. Of course we have our antibacterial footwear protection that is completely anti-pathogen. So this is something that we will actually be readdressing. Because of the success or the interest that people have had in the Hot Stuff concept and brand, we'll probably be also adding that into that for footwear, the Hot Stuff anti-pathogen coating. But that we know blitzes all pathogens. So I hope that answers the question. As it stands, biostatic. Is it antibacterial? No, because there are no agents inside it. But will it reduce bacterial growth? For sure. Any more questions?
Rian again.
Hi, Rian.
How many pairs of sneakers will you be able to coat with 200 ml approximately?
Thank you for another fantastic question, Rian. Right. The absolute clear answer is if you have two pairs of high top Converse sneakers, like these are my wife's size 5, and she's got the Nike type open weave modern sneakers. And reality, I would say 6 or 7 actually of those. It will, because there's so little fabric on them and whatever. If you've got a pair of high top Converse type training shoes, these are low top, and they're size 12, 13, big men's ones, you will get 2 pairs, because unlike this coating, which is our spray-on coating, we want it to go really everywhere inside, as though it's been dipped. And so we're going to put more in here than we would with a standard spray-on. On the standard spray-on, we're moistening the surface thoroughly. But with this, we want all the moisture, the liquid, to go inside everywhere. That's why you get such outstanding performance, because it's really, really inside. So I would say between 2 and 5 is a safe guess. And the reason we say that is if I had a size 10, let's say 10 in a modern training shoe, like my wife's ones, which are very standard, as I say, Nike woven ones, I would get 5 pairs of a size 10 for men. But we have to say, somebody comes along and says, right, I've got a pair of canvas shoes, a lot of moisture goes inside here, and we want this, to be quite honest, we want this to be the best in the world. We don't want to be like anybody else. This has got to be the best. If it's not the best, then it's just like something else. This will be the best sneaker treatment in the world.
Okay, Shady.
Hi, Shady.
Is asking if customers can use it directly and immediately as a ready-to-use spray bottle.
It always, will always come as a concentrate, because it's like a lot of these things. It's the nature of this that we don't want to leave it in a bottle for, could be 6 months or so. Like the stability, the performance will drop off. So we want this fresh. And if we supply they've got an empty bottle, they've got the bottle of concentrate, or the sachets, depends where you are in the world, you can't go wrong. You just take it, empty into the bottle, mix it, and it goes. So we're not selling it as a ready-to-use product, ready-mixed, because it's not a good idea, technically. I hope that answers the question, Shady. Any more? Right, so...
Radu asks, should the shoe be new when we apply the coating, or could it be done after wearing it?
Thanks, Radu. Great question. They're all good questions. All questions are good. You can apply it after if a shoe has been used, but it must be as clean as possible. So it makes sense that if it's got lots of oils and dirts and things on it, you won't get the best performance. Doesn't have to be new, just has to be clean. But because we're soaking these so much more than the others, it's a little bit more forgiving. If you spray this onto really dirty stuff, it's not going to bond. But this is going to get inside everywhere, and and you are going to heat cure it, so you're going to get a bit more. That on dirty things doesn't work. This, it will be okay, but it should be clean. Okay. So, bear with me a second. Right, what's our cut-off time? Is it 5 o'clock?
It's an hour. No,
We've got another hour.
1 hour. It's over.
So how long have we got?
You want to do 90 minutes?
90 minutes, yeah. That's what I was thinking. I've got it down, it's just double checking. So here's our fabric, it's our shirt, and here is the shirt from Marks and Spencer's. And here is our special wash thing. So that's been coated 1 to 20, and I'm just going to put that inside here. And if you were doing shirts and things like that at home, here's the shirt in here, you would, and this is very absorbent, this shirt. It's I must contact Marks and Spencer's. Now I could have made the shirt, because it's less going to take less wear and tear than the training shoes, I could have made this 1 to 30, but I've just used the same liquid. And that's pretty much absorbed all the liquid in there anyway. Just making sure that that's... In fact, what I'm going to do is make sure I'm going to put a bit more liquid in there. Just making sure that wasn't carbonated water. To make sure it is. And this is quite good because it gives us an indication that the amount of liquid that is going to be absorbed by a shirt, standard shirt, size 16, very cotton shirt, is going to be about 200. You would have to allow 250 mil for a shirt. Now, so that could be. I've done it with like a big. In fact, it's an ex-military camouflage jacket that I use for going walking. It wasn't very good. The hydrophobicity, and I live in Cornwall now, where it's very rainy, and so you want something that's going to be hydrophobic. And I did exactly the same as this. Just mix some liquid in, took it round, absolutely brilliant. Put it in the tumble dryer like new, absolutely brilliant. So that's well mixed in there. So you would take this, put it on the washing line, or put it in the tumble dryer directly. Now, it makes sense to put it on the washing line. Let the liquid drip off, and we're going to dry it with a hairdryer in a minute, just show you the performance. So, but I would recommend you always take it out, you put it somewhere to dry, and then you can then put it in the tumble dryer afterwards. In the tumble dryer, Most people, again, this will be in the information pack, you have to dry it and then say, right, this is dry, now I have to heat cure it. So, because what happens, you put that in the tumble dryer now, it's going to, because it's so wet, if you threw that in the tumble dryer with some other things, it's going to take 30 minutes for that to become dry. And whilst it's becoming dry, it's not as hot as people may think. It's still using, the energy is being expended in evaporation, not in curing. So all the time the moisture is going out, it's not getting to that optimum temperature. So when it's dry, you say, right, it's dry now, I want another 5 minutes of 50 degrees, 60 degrees in the tumble dryer. If that makes sense to you, I hope it does. So you're using the first period to dry it, and then you finish with an extra 5 minutes. If it was dry from the line, you take it in and put it in the tumble dryer for 10 minutes and it's finished. Okay, so we've coated our fabric, and we'd normally use a hairdryer, but we haven't got a hairdryer, so we're going to use a heat gun. Let's see. Now this is one of these, this is an industrial heat gun, so I've got to be very careful not to kill myself, or burn myself here. Or burn, would it be possible for you to take this out and do it?
Do what?
I was going to say, because otherwise, well, I couldn't do it here. Otherwise, you won't, I'll show you the process anyway. This is a bit like watching paint dry. Now this could be the training shoe, but we're doing this from wet. I would never recommend it. Doesn't make any sense. But I'm just showing you. Ooh, this is hot. This is not a hairdryer. In fact, Bert used it as a hairdryer. That's what happened to him. So it's getting dry now. It'll dry in a second. Now would be a good idea to ask a question while I'm drying this. Give it another few seconds. So that feels pretty dry now, and I don't know what temperature it's at, but it was pretty warm.
Dominic asked if the surface need to have a temperature of at least 60 degrees.
For the DIY, 50 degrees. You can start at 50 degrees. 50 to 60 is ideal, but not below 50, and not above 80. Well, you could do it to 100 degrees. If you, that's a point, I could iron this now, and that would guarantee it. But you can iron it as well. Ironing will also, it won't damage the coating. Not saying the hotter the better. But, so, I'll just give this another few seconds. Well, I've got an idea, but whilst I'm doing this, could you go through some of those the pictures of from the washing and so on? Bert's going to show you some of the photographs that he took after in the processing of the sneakers afterwards.
I cannot do it.
You can't.
It's not prepared.
You got what have you got in terms of images then? Sorry, I thought you had. It's okay.
No.
No? Okay. Yeah, I thought. This is brand new, so it's smoking out of here, so it's never been used before. Okay. Right. So that now would be, if it was a training shoe, that's all you need to do. and then you are going to get really fantastic hydrophobicity. Don't know if you can see that on there. Is there any way that could show that, Bernd? Pull this over here. If I fold that down to have a look. You see there? I don't know if you can. It's really, really hydrophobic. Super hydrophobic. But that's what we would expect. That hydrophobic, oleophobic, so we put our staining agents on there. Right. So that's what we do. So that's our training shoe. You've seen the effects. Washable minimum 10 times. Machine washable. So on a short wash, not on 2 hours at 900 degrees or something, but a short wash, it will come very, very clean. So if you were to do this with just a hand wash, that's all you need, because you find that the contaminants come out very, very easily. If you have got heavy staining, little drop of biosativa, of course, will work. So that's the core, the concept of the hot stuff. And the sneaker treatment would be coat the sneaker outside, or and let it dry, or put it in a room, let it dry. Then afterwards, and we think this is part of the thing for kids especially, that they will quite like to, with a hairdryer, not this is too harsh, but with a hairdryer, just dry the sneakers, and the younger people will enjoy that. The older people just put it in a tumble dryer, and then they're just going to get unbelievable performance. Again, they could always use this, but you're going to get better performance and washability with the hot stuff than this. This will give you 4 or 5 washes, I would say. This will give you 10 and better performance. Question?
Question from Rian.
Yeah.
When you mention co-branding, it means that we can use our local brand on the packaging together with hot stuff? Or
Yes.
do we also have to mention CCM on the branding? What are the requirements for co-branding this product in our country?
All of the packs will be we're controlling for the hot stuff. The shoe pack will be. Our vision of this is that it will be very valuable for all of our partners, because you would become the hot stuff. It will be your brand, hot stuff. So it will be I don't know whatever your company name is, and hot stuff contains hot stuff. So the hot stuff will be there wherever on the pack. So that is a case. We're not doing this as one of those that we're giving away. This is going to be always will have hot stuff in there at some time. Everybody knows that you're protected. You know what our process is like. But we feel that there is so much strength in the brand associated with this that people will want to be able to supply hot stuff. Anything to add to that, Bernd? Yeah. Any other questions, guys? So, if we were to look at this pack here, for example, it would be whatever your brand is there. You could have hot stuff at the bottom here, hot stuff at the side. That's what's going to be, the fact that it's got hot stuff in it is what we think. It's the contains lycra concept. That's what is important. So, the hot stuff, easy to use. You mix it, you swish it around, you soak it, sponge it, dip it, and you dry it. And then you're going to have great performance. You wash it again, put it back in the tumble dryer, and you're going to get great performance again. We'll do the shirt in a minute. You got a question?
JD, if you apply on shirt, do we need to wash before wear it for the first time?
So if you take a hot stuff from, I would always recommend, that's a really great question, Shady. I would always recommend that you wash it, because cheap, I know you would never wear a cheap shirt, Shady. Cheap shirts, especially out of India, come with a lot of starch on them. And the starch goes after one wash. But if you put it on a shirt that hasn't been washed, the starch will stay in place, and then you put the hot stuff on, it coats on top of the starch, and it will. So I would always recommend that if you're doing it, on a shirt. Like the Marks and Spencer shirt I've just coated, doesn't have any starch on. In fact, I tested it, it was like blotting, just went straight through. So I knew that had nothing on it at all. So, but if it's a cheaper shirt, and a classic example was, and I know this from Marks and Spencer's, they gave me a pair of chinos that they wanted to coat and protect, and I said to them, "Is there anything on the chinos?" And they said, "No, nothing on the chinos." And I put the coating on, which is a DIY coating like this, which you can use for industrial application. And it was great, and then after 10 minutes, it stopped working, and I couldn't work out why. And I said, "Are you sure there's nothing on here?" And they said, "Yeah, there's nothing on here." And very simply, they said, "Oh, apart from starch." I said, "Well," and so as soon as I washed the chinos, then recoated them, then I got fantastic long-term performance. So I hope that answers your question. Anything else?
Dominic, do we have to heat the textile after each wash cycle?
You put it in the tumble dryer again. You don't have to, but to get the really good performance, you dry it again, and then it's as good as new. It's really, what we're doing is giving high performance time after time after time. But the performance characteristics should be clear. The industrial variant is super high performance, and this is high performance. As I say, the industrial variant is ridiculously high performing, but because it's an industrial application, heated much higher, you expect that. This is like the baby sister, but there is nothing. If you go out and try and buy something that is a DIY, washable, hydrophobic, oleophobic, adventure clothing, ski jackets, anything that really works, there's nothing. It's this or nothing else.
Question from Ricardo: the self-healing is just for the coating, or also can affect the fibers? The washing cycles are influenced by the self-healing.
No, the self-healing is the coating itself. The heat rearranges the coating. So think of it as something that is stimulated by heat.
And the number of washing cycles?
Number of washing cycles, 10 to 40. 10 for cottons, 40 for synthetics. Cotton polyesters get higher than ordinary cotton. Cotton is the worst. So you're going to get 10 on ordinary cotton, and then it'll go higher. Okay? Right, we're now going to mix the industrial variant. And it's really very straightforward. We'll do that shirt in a minute. So, you now have to think to yourself, right, I'm dealing with a massive company, and you've told them, like I was talking to Ricardo the other day, you're dealing with a big shirt manufacturer. I'm meeting a really big shirt manufacturer on Monday afternoon, super big, and so you're in Portugal, Ricardo, and you say, right, I want to show the shirt manufacturer or test for something and this is how you do it. So this is our big 1,000 litres. Of course it isn't, we're just doing it as a small amount here. We've got 96 millilitres of water, and then I'm going to take, oops, excuse me. I'm going to take 1 ml 1 mil of the fabric SiO2 agent, and in that SiO2 there is a tiny, just inside there, it's nearly all SiO2, but there's a tiny amount of fluorine, C6, inside there. So it's 95, 98%, even more, silicon dioxide. Then I'm going to take the fabric concentrate, I'm going to take my heat bonding agent, and I'm going to put 3 mil inside there. The light's not so great now. Oops. That's 2. Right. And what you would do if you would have these bottles here. You wouldn't need to measure them. You'd have 960 litres of water in an IBC. You just tip them in. Then I'm going to put some wetting agent in. You don't actually need wetting agent in certain instances, but it's always useful to put it in. I'm going to put 1 mil of wetting agent. That allows it for flow in and around the fabrics. Sometimes you need that on very synthetic coatings, and here we've got our other special agent in. We're going to put 1 mil. Actually, it's 0.8. It's just short shy of 1 mil. Okay. As I say, you will just get these agents in a. That's all you have to do. Even less complicated than I'm doing now. Now this will have a shelf life of. We recommend it's used within a week. So if a company is doing a bath and they will use a ton of liquid in a few hours, it depends, really short in some big companies. So I've stirred it around, that's all I have to do. The next thing I would do is, now why I'm showing you this method is, imagine somebody says to you, okay, can you test it? And I'm going to show you how to do it in-house, because it's really very straightforward, and you want to be able to do it in-house. And so we take our fabric. If you can see here, this could be, I just need to moisten the fabric, and this is just ordinary cotton. Now in the manufacturing process, it will be dipped and squeezed out. So there is our fully moistened fabric, probably slightly more moist than an industrial process, because their squeezing technology is quite good. But that's all you do. So imagine that somebody has sent you a sample. So you cut it like this, and here is my patented, right, we need to get a bit of a close-up on this if we can. And this is what I've used for those people who've seen it before. Here we have, I only brought this on the flight with me today, so it's, I've had to I use this so we don't break anything. It could be a piece of wood. Here I've got an aluminium bottle, and if anybody buys the 640 from us, it's the same bottle. So I'm going to put heat inside there with our heat gun, and I've got a slot here, make sure that's not going to burn the carpet, and I've got a slot here, whoops, I'm going to put the fabric inside there. I've got holes at the back here to allow the air to pass through. This is just like they would have in it's a mini industrial dryer. So, and I've also got a little hole here for a thermometer. So, actually, this is a brand new thermometer and it's fractionally bigger, so I'll just put it down here. I've got a hole for I broke mine last week and ordered a new one, so this is the new one. I'll just put it inside there, it doesn't make any difference. So, you need to get a thermometer, that'd be $5 on eBay, ordinary thermometer, and make sure that you've got it to Celsius for me, because I don't do anything in Fahrenheit. And so the procedure is, what they would normally do is that in fact, no, I'll just do it in-house. They would normally blast it with hot air to dry it. That's the first procedure. Then they're going to heat it as soon as it's dry. It will then be heated for 60 seconds, 80 seconds, 1 minute, 2 minutes, depends on the thickness. But I'm just going to put that inside and dry gently to start with. When I think it's dry, I'm going to, when I think it's dry, then I will time it. So it doesn't really make any difference. We're just showing the procedure. So moisten fabric, that could be a million square meters, but this is the sample that somebody's sending you. You do this, send it back to them and say, this is the performance. So, we've got, as I say, I had to come on the flight today, and the one thing I didn't bring was my clothes pegs, which I use. So normally we wouldn't be doing what I'm doing now. I'm blasting the air inside this chamber. And the first thing I want to do is just dry it. Now the drying process is not curing it, not properly, it's just taking the excess moisture out. Now I could do it like I did before, but I'm just showing you. I could dry it like this, but I'm going to use the mechanical device. If you do this at home, make sure that you don't do it on a table, because the heat will burn the table underneath. So. Crank it. That's still not quite dry yet. Nearly there. Yeah, so that's dry. The bottom of that is dry. Top is a little moist, but I'm going to only test on this bottom bit. So Bernd, in a minute, could you time me for, because it's a little bit moist, I'm going to time 90 seconds. I'll do it, it's okay. Yeah, if you can hold that, it's going to be, make sure you don't keep your fingers right at the end there. I normally have 2 clips that are put on the, so how you would do this, you would have the thermometer there. Now this has got to be 160 degrees, so you'd have the thermometer inside that hole. I'm just putting mine here now. And you would time it for, I'm going to do 90 seconds at, so I'm going to watch the temperature rise. I'll talk to you as I'm doing it. Coming up now, it's 60 degrees. I'm just going to do it like this a bit. That's 88 degrees, that's 97 degrees. Yes, just Hold it by the end, the plastic end. Okay, just pop that there. Okay. I'll just do the bit inside there. So that is 121 degrees, and you only start, so it will be continuing to dry now. I'm just going to take the dryer there, that's 134 degrees, 140 degrees, right, 150 degrees now. So that was up to 165, so I'm now keeping it 160. So you can move it backwards and forwards like that. You would have a timer on there, that's 25 seconds, that's 160 degrees, so it's fine. So remembering this would be an industrial process, so it would be, if it's blasted air like this, they would know the temperature would be fixed all of the time, and you wouldn't have a guy looking at his watch. Right. Okay. So that is the process. So that now would be your sample from whichever company. We've dried that at 150, between 150 and 160 degrees for a minute. The heating beforehand was to get rid of the available moisture, and then we've heat cured it to that. And so that fabric there, you would, if you're doing this sampling at home, you would chop off the top bit, because that was, if you can see, this works absolutely perfectly, this test procedure. That top bit will not have reached 150 degrees. So you take it out, you chop the top piece off, discard that. That's the piece there that's been heated. So discard that, that's the test piece. You give it back to the people and say, that's the coating, that's how it works. As I say, there is, in the marketplace, there is nothing that will perform as highly as this. Question?
Right to ask, does freeze minus 20 affect the coating?
This coating, no. No. Temperature, it's very chemically resistant. Again, if you want to alter it to make it more chemically resistant, we can, like if you buy a garment and it says dry cleaning only, then you wouldn't want this coating on it. You would want this with a dry cleaning component on it. But for example, if you've got something like linen suits, they get damaged in seconds, and this is absolutely perfect for that. But so if you wanted to use it for people working in the snow and things like that in the cold, it's not an issue at all. And it's heat tolerant as well, of course. I mean, if you subject it to, it's fine up to 200 odd degrees, but and we've done some, that's an interesting point. We're doing some stuff, Burnt is doing it with fire uniforms, protecting firemen's uniforms to make them easy to clean and so on and so forth. So there's our coating. That's the procedure. But we know that, I mean, it's ridiculous. It's it's just ridiculously, I don't know if you can see that. We could maybe take that right under the camera. It's ridiculously hydrophobic and oleophobic. Oh, it's good. In fact, I put it. It's so hydrophobic. It's difficult for Burnt to keep it on the. You can't even keep it on the fabric. Put that there. Oh! I'll try it. I'll come over to the camera. it's not a very good background, is it really? I should maybe, whoops, pardon? This isn't going to work. Don't know. Higher. Here, I've got some coffee on here. Oh, it's going to go on the mic. Even higher.
Oh, okay, wonderful.
There's our coffee. Oops, it's gone. Sorry, Burns, on your computer. I'll get a tissue. Yeah. So I've ruined Bernd's computer by spilling. The coffee won't even stick on the surface, it's so hydrophobic. And so that's really how good it is. When I was at the training last year, I put olive oil on, and it was there for the two days of the training. And people, it's the olivobicity, considering the tiny amount of C6 in there, is just unbelievable. It's amplified is the best way I can describe it. So, any questions? So how long have we got? We're pretty much wrapped up now. So fellas, let me put it back together again. We're still persevering. This, if you wanted to do a car seat, or just quickly spray on a pair of shoes or something like that, car seat, let's take as the best example. That's the way to go. The DIY spray. If you have a detachable car seat, that one that you take off your car and put it on, and you wanted really great performance, then the best way would be the hot stuff, the one that we soak in. If you wanted to manufacture car seats, that's the best way. This is the cheapest as well by a significant margin. This is the least expensive because it's all bulk. Remember, this is only for bulk. It's tons and tons and tons. We wouldn't be doing for anything for small amounts.
Can you explain again the foulard application? Right.
There are so many different ways, subtly different ways of. So the question was, basically, how do you get the fabric onto the coating onto the fabric? It sort of doesn't matter. You can have dipping. You can have dipping it so it just goes through a bath and is squeezed out on rollers, and then it just goes. Then it goes over some heaters and then through an oven, and it goes onto a roll at the other side. You can have some people spray, and they just spray as it goes along. You've got a fine mist spray. Some people only want to coat one side. You can do that with this. And so they just want to have one side with some characteristic, and the other side they just want. So you can even have a fine mist spray, and the mist spray goes over, and a cloth type thing comes behind, and it doesn't go all the way through. So you've got that. You can have dipping, you can have spraying, you can have a machine that comes on and pushes it on. That doesn't really make any difference. It depends upon what the industrial user wants. So that
specifically foulard is
dipping,
squeezing.
Yeah, the dipping, squeezing is but that is so. Very simply, your fabric finisher will know exactly. They won't want to change anything. You will have to put the fabric on how they do it. The only thing that you would change in any way would be the heat tolerance. So you go along to a fabric finisher, and he puts coatings on all sorts of fabrics all day. Putting this coating on will be easy. The only thing that he's going to have to turn a knob about or change is the temperature, because he may be curing at 130 degrees, and he may have never heated to 150 degrees or 160 degrees. And so what he would have to do is have to either slow down the movement of the cloth, or you'd have to put a new infrared beam, infrared heater inside there. They buy them in great big, like big electric fire things. So they put an infrared bar inside that goes to a higher temperature. You know, but they won't want to change anything. They won't design a system for you really. But use it in any standard fabric application. It will be straightforward. It's the heating that the only thing you have to turn it up or down.
Ricardo's asking the alternative to the C8 is the industry. In the industry, is the main approach in an earlier step?
For Ricardo's question, 5 years ago it was C8 technology. C8 technology, 2 years ago everybody said, finished, we're not going to do anything. And the only game in town really is C6 or C4 for oleophobicity. There is nothing else out there at the moment. Now, just to recap, if your fabric people say, I don't want any C6 or any C4, and they just want hydrophobicity, waterproofing, fine. We give you this without any oleophobicity in it. So you've got the world's most hydrophobic, washable coating, but if you get olive oil on it, it'll go straight through. So that is the debate. A lot of people still want, if you're a car seat manufacturer, you will be saying this is fantastic. C6 with a tiny amount compared to everybody else. They'll be very, very impressed, believe me. If they say, no, we don't want any C6, we just want washability, then, which they won't, they'll want stain proofing for a car, for sure. And there's some car manufacturers still using C8, which is theoretically banned. So we are really ahead of the game in that respect. Remember, tiny amount of C6 compared to the rest of the world.
Okay, Rian asked if it's dangerous goods or not.
Not dangerous goods.
So no problem for
no problem for any of them.
He asked for pricing and availability of what stuff we sent by email.
Yeah, pricing, availability. The pricing for the industrial is ready to go straight off. The hot stuff we have that pack that you saw on there, we've still got a little bit of tweaking. Target is online in Germany. When is it?
March 1st.
March, yeah. So we're close.
Yeah. Okay.
Okay. So I think, come around, Bernd. We have to. We hope it worked for you guys. Hopefully we'll do some more. It's as I say, it's really simple. Don't think about it as complicated. It's water-based coatings that go onto fabric that are heated either a lot or a little or not at all. And this coating, nothing like it in the world. Believe me, check. There is nothing that offers all the performance characteristics of this in the world, and there is definitely nothing that offers the performance characteristics of this in the world. This is it, the only game in town, really. So we're really very, very enthusiastic about what's happening with the hot stuff range.